So now I want to go through and solve a few more equations using some of the tools we've already developed up to this point, okay? So let's take a look at this first one. Here we have a -8 plus 2u equals -20. Okay, so just like before, our whole goal here is that we want to isolate the variable, in this case it's u, all by itself. So we want to start moving things around so that we can get u all by itself. So let's start by adding 8 to the left-hand side here. And remember, since we added it to the left, we also have to add it to the right. That's going to allow us to cancel this -8. And what we're going to have next is 2u equals -20 plus 8. Okay? Or, more specifically, we're going to have 2u is equal to -12. Okay, because -20 plus 8 is equal to -12. Okay, we're almost there. Now we need to see if we can do one more step to isolate u by itself. So we're going to divide both sides by 2. So if we divide both sides by 2, this is going to allow us to cancel the 2's here. And we're going to end up with u is equal to -12 divided by 2. But -12 divided by 2 is just -6. So our final answer is going to be -6. Okay. Here we have 16 is equal to 5x minus 4. All right. Just like before, our goal is to isolate this x all by itself. So let's go ahead and start by adding 4 to both sides of the equation. Okay. Now, one thing I want to comment on here really quickly before we move on, it's important that you start by adding any constant terms like we're doing here. I want to expand on this a little bit. Okay, and the reason we want to do this instead of doing our division by 5 first is that remember, if we divide one side of the equation by some number, we have to divide the whole side of the equation by that number. We can't just isolate this 5 by itself, just divide that. You have to do, if you do it to one part of it, you have to do it to all of it, okay? So we want to try and make the right-hand side as simple as possible before we do any division. That way we don't have to deal with any messy division problems, okay? So we're going to start by adding or subtracting any constants before we do any multiplication or division. Okay, so we're going to add 4 to both sides, and that's going to give us a cancellation here, and we're going to get 5x is equal to 16 plus 4, or we get 5x is equal to 20. So now we can just go ahead and divide by 5. From both sides, these 5's will cancel, and we get x is equal to 20 divided by 5, but 20 divided by 5 is just 4. So our answer is going to be 4. Okay, let's take a look at this one. Here we have 5 times x plus 9 in parentheses is equal to -3u plus 37. Okay, well let's go ahead and start. There's probably multiple ways we can do this. First, we should change this. We should have the same variable. This is supposed to be an x here, so let's do that. Okay, sorry about that. So let me start over here with this. We have 5 times x plus 9 is equal to -3x plus 37. Okay. It's important that we have the same variable. If we don't have that, this becomes a totally different kind of problem. So there's a couple of ways we can approach this, but I think probably the best way to do it is to start by distributing this 5 to the x and to the 9. Now that might sound like we're making it more complicated, but this is actually probably going to make it easier in the end. So we'll start by making a distribution here. Because if we were to go ahead and divide away this 5 and just give us x plus 9 on the left-hand side, we'd have to divide the whole expression -3x plus 37 divided by 5, and that's not going to end up being particularly pretty. So let's just go ahead and distribute and see what happens. So if we go ahead and distribute, that's going to give us, if we distribute the 5 to the x, we'll get 5x, and the 5 to the 9, and we'll get 45. Okay, so we have 5x plus 45 is equal to negative 3x plus 37. Okay, so from here, we want to continue to see if we can get all of the x's on one side. Okay, we're trying to isolate x by itself on one side of the equation. Okay, so here, what I'm thinking is we can go ahead and add this 3x here to the right-hand side, but remember we also have to add it to the left-hand side as well. So that's going to cancel this 3x here, and now we're going to have 5x plus 3x plus 45. That's going to simplify to 8x plus 45, and this is going to be equal to 37. Okay, so next we can take 45 away from both sides, and this will allow us to cancel this 45 with this negative 45, and we're going to get 8x is equal to 37 minus 45, or we'll have negative 8. 8x is equal to negative 8. So now we can divide both sides by 8. This will cancel, and we're going to end up with x is equal to negative 8 over 8, which is just negative 1. Okay. We move all this down. So we have room to work here. Okay, so next we have 6 times u plus 4 is equal to negative 7u minus 41. Okay, so just like last time, let's go ahead and distribute this 6. Okay, and again, the reason we'll do that is because if we'd have to divide negative 7u minus 41 by 6, that would probably end up getting pretty messy. You would end up getting to the exact same answer. It would work, but it would be a messy process to get there. Okay, so let's go ahead and distribute first. So if we do that, we're going to end up with 6u plus 24. So we have 6 times u and 6 times 4, which gives us 24. This is going to be equal to negative 7u minus 41. Okay, so we have a couple choices. We can either move this 6u over here, or we can move the negative 7u. I like to keep the variables positive, so what we're going to do is we're going to move the 7u from this side to this side. Okay? All right, so when we do that, we'll have 13u plus 24 is equal to negative 41. Okay, so remember, our goal here is to get the u all by itself. So we are going to go ahead and take 24 away from both sides. Okay, and that's going to give us 13u is equal to negative 65. Okay, and if we divide both sides by 13, we'll get u is equal to negative 65 over 13, which divides cleanly, and we just get negative 5. So not too bad. Okay, so next let's take a look at this one. These next two are going to be a little bit interesting. Here we have 3 times 2 plus u minus u equals 6 plus 2 times u plus 1. Okay, so let's start by doing some distributions. Here we can do the 3 to the 2 and to the u. Okay, so that's going to give us, we'll have 6 plus 3u minus u. And then here we can distribute the 2 to the u and to the 1. So we'll have equals 6 plus 2u plus 2. Okay, so now let's see if we can combine like terms on both sides of this equation. So here we have 6 plus 3u minus u. We only have one constant term on the left-hand side, but here we have 3u and negative u, so let's combine those. So we'll have 6 plus 2u, because 3u minus u is 2u. Okay, and over here we have two constant terms, 6 and 2, so we can add those. So we have 6 plus 2 is 8, so we'll end up with 8 plus 2u. Okay, so now we want to see if we can get all of the variables on one side and all the constants on the other. So let's start by bringing this 2u over here. And that's going to give us, these will cancel, and we'll have 2u minus 2u, and oh no, this will also cancel, right? Oh boy. So we have 6 is equal to 8. Well, that's kind of a problem, right? So when we end up with, if you do all of your distributions, cancellations, combining like terms, you go through all of these steps, and you end up with some equality here that isn't actually equal. It's nonsense. Okay, obviously these are not equal. 6 is not equal to 8. If you end up with something like that, we have a way of handling this. We say there is no solution to this equation. So your actual answer is going to be no solution. And I think on ALEKS, there's just a little box you check for no solution if you end up with an equation that's going to have no solution. Okay? So this would have no solution. Now let's take a look at this one. Here we have 5 times v plus 1 in parentheses minus v. And this is equal to 4 times v minus 1 in parentheses plus 9. So let's first start by moving this to a new page. And then we're going to do a distribution here. We'll distribute the 5, and we're going to distribute the 4 as well. So if we distribute the 5, we'll end up with 5v plus 5 minus v. This is equal to, if we distribute the 4, we get 4v minus 4 plus 9. So next, we're going to combine all of our like terms. So we have 5v, and then we have negative v here. So this is going to give us 4v plus 5. And that's going to be equal to 4v. And then we have negative 4 plus 9. That's 5. So 4v plus 5. Well, maybe you see where this is going. Here we have 4v plus 5 is equal to 4v plus 5. That's true. But if we want to convince ourselves even more, we can take 4v away from both sides. Okay, well, this will cancel this 4v here, but it'll also cancel this 4v. So we're left with a similar situation to last time. We have 5 is equal to 5. What's different this time is that this equality actually does hold. So this works. 5 is equal to 5. In this case, we have kind of the opposite situation. In this last example, we had no solution. And here we would say all real numbers. Meaning you could plug in any real number that you want into this equation here, and it should hold, right? So you can plug in any number for v, and it will work. Okay? So if you don't believe me, go pick a random number and plug it in and see if it holds, right? So this is a trivially true equation. So there we go. So these are your two other possibilities you'll end up with. You could end up with one solution, like we've seen from most of these examples up here, or you could end up with no solution, or you could actually end up with an infinite number of solutions. These are all possibilities here.